Imagine that you wanted to be able to create not just one map for one story, but hundreds of maps or dozens of maps for multiple stories or multiple newsrooms across a particular country or a collaborative project. That was the problem that I faced when I was working on a story about flood defences. We'd worked on this story, we'd identified which flood defences were particularly in poor condition, which parts of a country had most flood defences in poor condition, and things like that. But those gave us a national picture, but we also wanted to be able to share maps with different newsrooms across the country so that they could tell the story about their area. Or indeed, you might be in another situation where you want to generate a website with pages for each part of the country, and each of those pages is going to need a map for that particular part of the country. So that's what I'm going to walk through in this video, what we do to go from a single map for a single story to dozens or hundreds of maps for lots of different newsrooms or different readers or different audiences. And to do that, we're going to use the geographical mapping software QGIS, which is very powerful, and it allows you to use Python. So the other thing we're going to do is we're going to use a Python script to automate this process of creating multiple maps. Now, you don't need to write any code for this. I'm going to talk a little bit about how you deal with that challenge. But we're going to work through QGIS, and we're going to load a script and then adapt it. Everything for this walkthrough is on this GitHub repository. So it's github.com/paulbradshaw/QGIS and on the first page there is all the details, including the files you need to download and a series of walkthrough step-by-steps. So I'm going to follow these walkthroughs, but you can go to the repository and get the step-by-steps in more detail. I'll put a link underneath the video. But the one file we're going to need to download is some flood defense shapes, and this link takes you to this page here. And what we're looking for here, when you're mapping something, you're looking for something called shapefiles, or sometimes GeoJSON. A shapefile has .shp in it, and we can download this zip file here. And that will include actually more than one file, but we're going to need all of them to create a map of these flood defences in QGIS. Now, in other tools, you could also use GeoJSON, but we're going to use a shapefile for this. So that's the one file I need. All the other files are in this folder, and we can actually download them all by clicking on the green code button and downloading this whole repository as a zipped file, a folder that will then contain everything. So that's what I've done. I'm not going to download any other files as I go through. What I do need to do is open QGIS next, and I need to create a new project. And in this project, I need to add that layer, those shapes that I've just downloaded. So I'm going to go to Layer, Add Vector Layer. And I'm going to go off and find that dataset that I downloaded. I'm just going to check if I've put it in my folder. So I'm going to put it in my project folder first. So now I can go and find that. In fact, I'm going to go into my project folder here, and this is that zip file that I downloaded. Now I'm just going to unzip that. So here it is, and you can see it's got 4 files in there. So I'm just going to go through this process again. Layer, Add Vector Layer, click on the 3 dots and find that folder, and then the shape file within that, so the file ending .shp. Click open, and then click add, and in the background here you should be able to see the shapes that you've just added. So I'm going to close this so we can see it in more detail. We can see the kind of outline of the country, but the actual country isn't there. This is just the shapes of the flood defences in this country. So we're going to need to add the actual country as well in the background. We get this orange alert appearing. This tells us that it has done some sort of transform. What these refer to are different projections, basically different ways of drawing maps, because what we're drawing here is not a flat surface. The Earth is not flat. It's a sphere, but we need to draw geographical features, countries, things like that, from that sphere onto a two-dimensional surface, a screen here. So that's what both of these are. These are two different ways of doing that, two different ways of drawing a curved object on a flat surface. And it's done a transformation. Now, I'll explain a bit more about that in a moment, but we don't need to worry about that. What we do need to do is add another map as well. So we need to add the country behind. And these XYZ tiles on the left, XYZ tiles, are 4 different ways of adding some satellite imagery. And I'm going to use OpenStreetMap. Now, I can click and drag that into the layers there, or I can just double click it and it will add it to the layers. So we can now see OpenStreetMap is on there as well as flood defences. And we get a window appear as well, which talks about another transformation. And again, we've got these two numbers, EPSG 3857 and EPSG 27700. The short version here is you just click OK, but what it's doing, what you're agreeing to, is it's going to convert, it's going to transform OpenStreetMap's projection, which is called 3857, pseudo Mercator, or Mercator, however you pronounce it, and it's going to convert that to another projection, 27700, which is British National Grid. Now, the reason it's doing that is that the flood defences use this projection, 27700. And we're going to make sure that both of these are the same. So I'll click OK. It will convert OpenStreetMap, so it's using the same way of drawing itself as the flood defences. So they should line up. And that's another reason to import your shape files first, because that's the projection you want to use. So the other thing is we've lost our flood defences now, so that's because they're hidden underneath the other layer that we've added. So just click and drag that so that the map, OpenStreetMap, is behind or below the layer with the defences on. So you can now see those flood defences in green. Now, green isn't a very useful colour here because it's easy to confuse that with the map behind. So we can customise now these defences to look different, to have a different colour, to be a different thickness. I'm going to zoom in first. So we're looking at this map in the same way that we might do in a story. So I'm going to zoom into one of these towns, and you can do that by using these plus and minus magnifying glasses, or you can use your mouse scroller if you've got a scroller on your mouse. I'm just checking if I can actually see any flood defences. It's very hard to see. So right click on spatial on the flood defence layer, go to properties, and this is where we can customise the colour. So we definitely don't want it to be green. Let's just make it black for a moment. We can make it a bit thicker. We can make it semi-transparent, so I'm going to take that down to about 40%. And if I click OK, it will apply and take us back to the map. But if I just click apply, it will keep me on this window and the changes will be applied in the background. So that's quite useful to not have to keep opening this window. But we can see those flood defences in the background. And we can customize this a bit further. So perhaps we might want the thickness to be a bit narrower. Let's see what happens when we do that. That's okay. We might choose a different color. Blue might be a bit too confusing. Let's see what pink looks like. Okay, that's certainly distinct in terms of it. You know, we're not going to mistake that for something, an actual geographical feature. You can play around with these colors and this transparency until you're happy. And then click OK to come out of that property editing menu. Now, I've zoomed in again. I'm just going to edit it one more time. I'm going to change this color. Let's just go with a pretty boring black. Okay. So once you're happy with that map, we can then go through the process of exporting a single image just to get a feel for the sorts of dimensions, the scales, and other things that we're going to need. And one thing to draw your attention to here is this scale area at the bottom. Now, at the moment, it's 1 to 86,663, and we could make that a simpler number by editing that directly. And that scale is going to become important later as we start to loop through these. So maybe we try 65. 65 really zooms in, but that's okay. That's a decent map. So at this point, we've got a base map. This might be a map that we use for one story, but we need to export this as an image. So to do that, we go to Project. You can go directly to Import Export and do it here, but there's also a print layout option. So you give it a name, click OK, and this new window appears with that name you've just given it. We want to draw a map on top of this. So you use this button on the left to click and draw across your canvas. You can draw across the whole canvas, and we've got that map that we were looking at. And on the right, we've got the properties of this map. So this is where the scale becomes important. We can change it to 85,000. We can change it to 65,000. And once we're happy with that, we can also look at other properties like position and size. So here we've got the width and height, which is currently A4, 297 millimeters wide. We could change that to pixels. And we can also look at the layout option here to set any properties around things like margins and other properties. But I'm just going to leave it there for now. I'm just going to save what we're doing. It's now going to ask me to save my whole project because I haven't actually saved the project yet. But this now gives us some ideas about what our images are going to look like. But we don't just want one image, we want to automate this. So this is where we start to use some code. And to start to use code in QGIS, you need to open the Python console. This is an area of the screen, a window that allows us to see and run Python. And to open that console, you go to Plugins and select Python console from that menu. And here it is opening at the bottom. At the moment, this is just a big kind of area where you can run code. So this part at the bottom here is where you can write Python directly and then run it. And then the larger area above it is where you see what happens when you run the code. But writing code directly into this area is not going to be the most effective way of running Python with a map. We want to write a script, save that script so we can use it and edit it time and time again, rather than typing it into here and then it disappears. So we want to not just have this Python console open, but we want to have a Python editor open. And you can open that by clicking this button here that says Show Editor. Now that opens another area to the right here. I'll just close these two because that's a bit of a spoiler alert. It will normally open like this with an untitled file on it. And this is where we can write a script and save it. So we could write what we did before, but this time we could save it as an actual file. Or we can open a file that we've already found elsewhere or created, and that's where we need, if I go back to the GitHub repo, that's where you have the Python code. So where are we up to? We're up to step 3 in the walkthrough, and here we go. It talks about a file called QGIS_take_pics.py, and this is what that file looks like. Or if I go back, it's also in the repository here, and you can download it by clicking on the 3 dots and downloading it. Or if you downloaded the whole folder, it's already in there. So I'm going to open a file and I'm going to go to, this is the script that I downloaded along with everything else from this project folder. Open that script and you can see here all the Python code from that in that script. Now that Python code does a whole bunch of things, so I'm going to quickly rattle through what it does. This area imports a whole bunch of, in fact this area, a whole bunch of Python libraries. The first bunch are a special collection of libraries, or a library that is related to QGIS. So you can see it says from QGIS import various things. Then there are some other libraries to do with dealing with numbers and text and files. Then this area here is quite key. There's only a couple of things that you may need to change in this. One of the things you might need to change is this, because what this does is specify where the images are going to be exported to. And what it says is find or create a folder called downloads, and then find, or more likely create, a folder in that called QGIS images, and that's where these images are going to go. Now if you get an error later, or if you want to change this, you can specify another place for the images to go, and you do that with this line here. At the moment it points to a users folder, and then Paul, and then downloads, and then test QGIS, and then images. But you can change that to whatever path you want your images to go to, and make sure you delete the hash so that it works. At the moment this is just a comment because it's got the hash, but if you remove the hash, it stops being a comment and it starts being a piece of working code. And this will overwrite essentially what's said above. And you could edit that in the Python here. So you can see that code here. If I delete that hash, we can see it becomes active, and I can change this and save it and it would go somewhere else. But I'm going to leave it as a comment. Now, going through the rest of this code, we have a converter basically, which is going to convert between our two projections. Now, if you were using maps with different projections, you would change this as well. So we can see it goes from 4326 and converts it to 27700. There's some code that creates a layout, and then it adds a map to it and borders and things like that. It sets a label. It centers the map on a particular location that's going to be provided later. And then this is the next key bit of code that you will probably need to change, or we certainly will change it later. And that's a list of latitude and longitudes and names of places. So we start with two locations, two places. We're going to loop through these and create two maps just to get this going, and then we're going to replace this with a full list. Then we set the scale of a map. Again, you could change this. We were looking at a more zoomed in scale. We set the size of the image, and then we loop through that list of locations, and all this code here basically creates a different map for each location and then exports a image for that. So that's the code. And you can just use that and adapt it for your own locations, your own map. To run this code, you press the play button. So I'll press that green play button there. And you can see in the console area on the left, we get any outputs from this code. So this code, if I go to the start, there's a print command right at the start, and that creates this output here. Then there's another print command here, which creates this output in the console, and so on. There's quite a few print commands, and it just helps keep track of where in this code we are, which bits are running. And then towards the end, we can see it writes a file ending in .png and a second file ending in .png. So we've got the two images for the two locations that we wanted to create. And we can find those. So let's just bring that folder over. You can see them here. This is that folder in my downloads with the images. So it's worked. And in fact, if I open one of those, we can see, I'll just close the previous one, we can see that's Adur at 1 to 175,000. It's added that label, which is quite helpful. It's named the file with the location as well. And let's get rid of some of these because these are from previous playing around. I could change this script. Let's change it to 65,000. Now we'll get an asterisk, which just tells us that this hasn't been saved. So if I save that, it will disappear. And then if I run that again, it will give us the same output again. It will create those two files. And if I now open Adur, we can see this is a closer crop. The scale in the label is different. And this trial and error is going to be useful in getting our maps right before we unleash this on a full list. But that's basically your Python script and how you run it in the console. Now then, we can move on to using that on a whole list of lat longs. And again, in the repository, there's a guide to this. One of these, there's a number of ways of doing this. First of all, you need a list. You need a table of locations. In this case, I've picked a list of major cities in the UK, and this is what that list looks like. We need the latitude and longitude. That's really important. We need a name. The rest we don't need. But we need to convert this table into a list that's going to work in Python. So basically something that looks like this. And what I've suggested is there are various tools online which will do this quite quickly for you. One of them is called CSV to JSON. And what's quite useful about this is it just gives you that JSON, that list basically that we're describing in a text box like this. So I'm going to go back to my project folder. Here it is. And here's my list of cities. Let's just check I've got the same name. This is GB cities. Yeah. So I can upload that CSV file to this tool. That's my list, and I can convert it like this. And then I can just copy that and go back into QGIS, and I can either edit the file directly or I can do it here. Now, one thing I haven't mentioned is that JSON is basically the same thing. It's a list of dictionaries. So this bit here is a dictionary, a Python dictionary, which is a way of describing data. So these are like column headings and these are like values. And this square bracket indicates a list. So the list starts here. The first dictionary is the first item in the list. Then there's a comma, then the second item in the list, and so on until right at the end the list ends with a closing square bracket. But all we need to know is to copy that to our clipboard, and we can delete the list here and paste what is now an enormous list of locations. Now, one thing, I'm just going to undo that so you can see, one thing we need to remember is we had lat, long, and official name. So if we paste, our list, lat, long, and city, these are different names. So the rest, either we need to change that in our data or we need to change it in the code itself. So I'm going to take the easy way out and I'm going to edit the data. Let's just go back. So I'm going to delete the data I don't need. I'm going to make sure that that's called long. I'm going to make sure that's called official name. Let's just zoom in a little bit so you can see that better. Okay, so the three columns now match what we had here, lat, long, and official name. Now I need to make sure I save that. And then when I go back to this, and I drag my file on this time and click convert, now we've got just the three columns and we've got the right names that we wanted. So that's just one important thing to check as you're creating your new list. Now I can delete the old list and paste this one in, and I can start to test this full list. But again, I don't want to loop through hundreds of cities straight away. I'm just going to go down to this loop here, and I'm just going to limit this loop a little bit, and to do that I can put some square brackets immediately after the name of the list and say just loop through, let's say items 10 to 20. It will stop just before item 20, but it will start at the item that's at the 10th position in this list, and it will carry on until just before it hits the 20th. If I press play now, this will take a little bit longer because it's going through more items. And so we can see it's done Coventry, Belfast, Bradford. It's going to go Beach Ball of Doom for a moment. While it's doing that, I can show you the folder so we can see those files appearing. And we can see the script is finished. So we've got the 10 files that it produced, plus the 2 that we used, that we created before. We can open up one of those. So that's Norwich, that looks okay. That's Plymouth, that's not too bad. Westminster is probably a bit further away than we'd like it. And Wolverhampton is probably a bit closer than we'd like it because Wolverhampton extends a little bit beyond that. So this gives us a sample to start to check whether we've got what we wanted. Now that's the first stage done with. That's if we are happy with that and we're going to use the same scale for all images, we can now just run this on all of the list and check a bigger sample, and eventually we've got a full collection of images, a full collection of maps. But I'm going to add another stage to this, which is what if we wanted to create images at 2 different scales? What's going to be quite likely in our scenario is that some cities are quite compact and we can zoom in at a smaller scale like we have done here, but some cities are part of larger conurbations and actually they extend beyond the scale that we've chosen. If we wanted to do that, we could add some extra code to that as well. So if I go back to my repository, my GitHub repo here, the final stage of this walkthrough is adapting our code. And this is where we start to get into, okay, could we use AI to adapt this code, or indeed any code? It's quite a useful tool to take a tutorial or take a template code, piece of script like you've got here, and start to adapt it for your particular project. So what I've put in the repository is a template prompt that would help you do that and also address some of the risks in using AI for coding. So deskilling is one risk. Explainability is another one. We want to be able to explain this code. So what we do in this template prompt is say, you don't want me to be deskilled, please add comments, please make it simpler if possible, and warn me about potential mistakes. So we're going to want it to push back a little bit. And then you can attach the script from before and ask it to adapt in the way that you want. So you can do that, or you can just open the second file, which is QGIS take pics 2 size. And I'm just going to do that here. And this is very similar to before. In fact, I'll look at it on the screen here. So the script, a lot of the same script. There are just a couple of key differences to draw your attention to. The main one is this. So instead of having 1 scale, we set 2, and we put those 2 different scales in the list. And then inside this loop that loops through each location, it now also loops within that list of scales. So for each location, it then goes through each scale, generates an image and exports it. So I'm just going to run that straight away, and then you can see what the images look like. So you can see now we've got, what it also does is it basically adds the scale to the end of the image. So we've now got a 25,000, a 75,000 and a 120,000 scale image for each of these areas. So for Coventry, we might have a look at this image and decide 25,000 is too close, but 75,000 is okay, and 120,000 might be too far away. You will know your patch, so in this case this does capture this other area, which may well be quite important. But that's the process, that's the walkthrough. As I said, there's more information in the repository. The walkthroughs are there in full. This is just a video to show you what's happening at the same time.